So today we discuss dual nature of radiation and matter. That's a very important chapter. So, dual nature of radiation and matter. Okay, that's a modern physics chapter. So that's a very easy chapter. So here we discuss what is the dual nature radiation here. Okay, so we know that Maxwell equation of electromagnetism and Hertz experiment. We know that the Maxwell equations, Maxwell's equation of electromagnetic waves. There is the Maxwell's four equation and the Hertz experiment. Okay, so this shows that electromagnetic wave. So light is an electromagnetic wave, or the Hertz to combine shows the light is an electromagnetic wave. In the year of 1887. Okay, so that's the nature of light. So we know that light is an wave nature. Okay, so here in something at same time, so okay, the conduction of electricity was investigated and with the help of discharge tube. Okay, at the same time, almost after I think 1 or 2 years or something, 5 years in between these two, the electricity was investigated with the help of discharge tube. So there is a discharge tube, and the tube is look like this. There is the tube, okay, and inside we place it two metallic plate here, one plate here, another plate is here, also called electrode. These two black are electrode, okay, and connect negative here and positive. One electrode connect to a positive and another electrode connect to a negative. Okay, and this tube is called discharge tube. Okay, this is called a discharge tube, and there is a pump. Okay, there is some pump here. Okay, I release the pressure air from inside and maintain inside the tube pressure is 0.001 millimeter of Hg. Maintain the pressure inside the discharge tube. Okay, now here we place a electric field here. Suppose a negative connect this plate and positive connect here, and so there is a electric field is generated here, and we see that some part of a particle, okay, released from this plate, okay, and move towards a positive plate. And I say that this plate is called this electrode, or is called a cathode, and this plate is called anode. Okay, so there is an electric field and some charged particle released from cathode and moves towards anode, and see that the negative particle are charge negative part point connected to this plate. So that's why some negative particle released from here and move towards a positive. Okay, because there is an electric field. Okay, so there's a high voltage generator and vacuum pump here, and we get a discharge tube, and here we get some flow of charge here. Okay, the very important concept here, we get some flow of charge, okay, moving cathode to anode. Okay, clear? That's the discharge tube, and when these charged particle move negative to plus, and we get some current here. Okay, so that's the electricity and in we discuss the discharge tube or photoelectric effect in some later of the portion in this chapter. So here is just basic idea here. That's a discharge tube which look like, and that the electricity was investigated with the help of this discharge tube concept. But later we discuss what is a discharge. Later class we discuss what is a discharge tube. Okay, here there's some basic idea. Okay. Now at that time, X-ray was invented. Okay. So that X-ray, okay, was invented by Rontgen in almost 10 years, 18 from 1887, 1895. So almost 8 years. Okay. And that time, these some ray, this ray is called cathode ray. Cathode ray, because these particles, we know that there is some wave nature of light. Okay, so if I consider these are that a ray wave, or consider light here, so this ray is called a cathode ray, because these charged particle released from cathode and move towards the anode. Okay, so at that time, after 2 years from X-ray invention, discovery that that electron, Mr. J. Thomson in 1897. Okay, J. Thomson invented the electron. So they described that the cathode ray are the stream of negative charge particle, and that negative charge particle is called electron. That's the concept of J. Thomson. Okay, they discovered that these cathode ray are the stream of some negative charge particle, and that negative charge particle is called electron. Okay, if I combine that X-ray, electron, and discharge tube concept, and for the Maxwell equation, the Hertz experiment, okay, for that important that we get some a perfect atomic structure for better understanding of atomic structure. Okay, this discovery help us to better understanding of better discoveries of better understanding of atomic structure. Okay. Okay. So here we see that their discharge tube maintains some pressure. Okay, and we get some concept here. And this cathode ray, I say that is a ray released from cathode. Okay, so that's a cathode ray, and that's also discovered in 1870 by William Crookes, or 1879, approx 1 year 79. Okay, so William Crookes discovered the cathode ray or cathode ray tubes or like that. Okay, and this almost 1870s, approx 1870s, discovered the cathode ray. Okay, and okay, the ray from the cathode and consider the stream of the fast moving of negative charge particle. Okay, the fast moving of negative charge particle. Okay, that's called cathode ray. And the J. Thomson, the very important scientist, the J. Thomson concept here, the Mr. J. Thomson, the concept is that the J. Thomson first determined that the charge of E by M ratio, charge by mass ratio. So J. Thomson here defined E by M ratio, charge by mass ratio. Okay, and they found that ranging of charge by mass ratio, okay, for that cathode ray, is almost equal to 0.1 to 0.2 times of speed of light. That's a very important concept. Okay, so J. Thomson concept that charge by mass ratio. Okay, actual charge by mass ratio is a measurement. Okay, this is a measurement, but some calculation with the help of that time. Okay, almost 1900, early 1900. Okay, the charge by mass ratio is the measurement for the electron or any cathode ray are the same E by M ratio. Okay, so 1887 it was found that a certain metal. Okay, the concept is as a dual nature is in a dual nature concept. Okay, in 1887. Okay, the concept is that some metal. Okay, some metal. There is some metal. Okay, and metal we have some a positive charge and some negative charge are free here. The free negative charge. Metal have free negative charge and is called electron. Free negative charge. Okay, free charge here. And some metal is irradiated by UV ray. Okay, and when irradiated means some UV light falls on a metal surface. Okay, suppose some UV light. These are the UV light falls on metal surface, and these electron are called free charge are excited. Okay, and if they excited, so means gain some kinetic energy, and when they gain some kinetic energy and this electron escape from metal surface and move to the another plate here like that. Okay, so if I plate a more positive here, we get a more positive potential field here, and there is a more negative field here. So there is a electric field here. Okay, there is a high electric field here. So that's why this surface, this metal surface, have some a free charge, means a free electron, and that gives some extra energy with the help of electric field, and that excited energy to overcome that the bounding, okay, the attractive force of that metal and leave from that metal surface and moves towards the anode plate. Okay, that's another concept. When a light fall on metal surface, that these are gain some energy, and that is a gain of kinetic energy and move that release from metal surface, escape from metal surface and move from any other direction. Okay, and if I replace UV light with some temperature, someone say that if I replace the temperature, I get some temperature put here this metal surface, and these electron may be excited, and also this electron escape from metal surface and move towards any other direction. Okay, escape. Okay, so temperature also the important factor here, and also UV light gives some energy to a free electron to escape from metal surface, and when the free from metal surface and move the direction, and if the free charge is moved, okay, that's why we get some current. Okay, we get some current, and these are that electron. Okay, and if I this free charge are removed from this metal surface, and E by M ratio of this escape metal surface is same as the electron, also same as cathode ray, is same as electron, same as electron and cathode ray. So concept is clear. So now if I extra electric field, similar like that, if I place a field here, okay, suppose there is a metal, some negative free electron here, and there is some, we place a positive charge here. So we get some electric field here, there is a high electric field, and that's why this free electron gets some energy and means a kinetic energy and release from this metal surface or escape from metal surface and move towards this plate. Okay, this is another potential. If I place a electric field outside that metal surface, okay, do we get some extra energy here from this electric field? Clear the concept is when that some UV ray and temperature difference, if I put like a heat energy, also place an electric field, these excited that free charge and release or escape from metal surface and move towards the another plate. When the free charge is moving, we get some current. So J.J. Thomson the moved that the particle of electron like the 1887 when that time he invented that. That's why he awarded the Nobel Prizes. And another scientist is called R.A. Millikan. Scientist name R.A. Millikan. The famous oil drop experiment. Drop. Actually, in discussion of oil drop experiment is not in our syllabus, so that's why I do not discuss the what is the oil drop experiment here. And he precisely measured the charge of an electron. So Millikan, so with the help of this experiment, he defined the charge of electron or free charge here. Okay, and he found that the charge of an oil droplet is an integral multiple of the elementary charge. And he found that the charge, that for oil droplet, oil droplet yes, was integral multiple was integral multiple of the elementary charge. The charge of an electron is the integral multiple of elementary charge. Okay, and that concept, the elementary charge, that is E, that is almost equal to 1.6 into 10 to the power minus 19 coulomb. Okay, and the Millikan experiment actually established that the electric charge is quantized. The main concept of Millikan experiment established the charge is quantized. Charge is quantized. Okay, that is Q equal to NE. Okay, and that is N equal to plus minus 1, plus minus 2, etc. And E is that charge of an electron. That's the elementary charge of electron. 1.6 into 10 to the minus 19 coulomb. Okay, clear? And Millikan concept is very important here. Now we discuss electron emission. Here, like that, here we discuss the electron emission. Okay. Now we discuss a little bit depth about discussion of the electron emission. What is the electron emission? Why the free charge is free from metal surface and move towards any other direction? It's called electron emission. Okay. Suppose here we see that a metal have free electron, and that free electron is called free charge here, and there is some positive charge, obviously minority, mainly major charge carrier is a free charge. Okay, and this free charge is main for responsible for conductivity. Okay, conductivity means the conduction of electron or a current flow. Okay, these are mainly, these free charge are main responsible for conduction. Okay, so here if an electron attempt some out of metal, okay, if a electron like a free charge attempt to release from escape from metal surface, they need some energy. Okay, they need some energy, and that energy they get from a, suppose a light, UV light, some temperature, heat, and also some potential field here. Okay, electric field. The light one, second is a heat or temperature, third is a field. The light, energy or heat, and there is a field. Okay, these three are very important. So the electron gets some extra energy to release from metal. But here is a point: when electron release from metal or escape from metal, like sodium, suppose you consider sodium a metal, there is the electronic configuration is 281. If one electron, suppose these are free electron, release or escape from metal, so if he escape from metal, So sodium gives a positive charge. This electron is a negative charge. So we know that this positive and negative, there is an attractive force here. So if a electron escape from metal surface and so metal get positive ion and this electron is a negative ion, and we know that these are the unlike polarities here. So there is some attractive force. So there is some attractive force here. So if he try to escape from metal surface, but this attractive force back to the same metal surface. Okay, so now the electron back to metal surface is called attractive pull. Okay, so certain minimum energy. So we need a certain minimum energy. Not all energy is possible from electron escape from metal surface. Okay, all energy is not possible. There is some minimum energy. Okay, some parameter here. Okay, suppose some energy called suppose 10 electron volt or 100 electron volt, or some metal have 1000 electron volt. Okay, these are that energy acquire from suppose a field, heat or light. Then the electron jump from the attractive force more than the attractive force. Electron gain some energy. That energy is and also the gain some energy, some kinetic energy, and that kinetic energy faster moving the electron, and they overcome that attractive force and now finally release from the metal surface and move towards any other direction. Okay, there is certain minimum amount of energy to require that an electron or free charge here, okay, to escape from the metal surface. That minimum energy required by the electron escape from the metal surface. Okay, and that minimum energy is called work function of that metal. Okay, so needs some minimum energy, and that the minimum energy, this minimum energy is called work function of metal. Concept clear? Work function of metal, and that is called phi naught. The symbol is phi naught. Work function in the metal is phi naught, and there is the energy. So that's the energy is electron volt. Okay, the minimum energy to gain the electron or free charge, and that the energy overcome that attractive force and release from the metal, escape from the metal and move to any other direction. Okay, so what is the 1 electron volt? They define the 1 electron volt is very important in board exam. Okay, that's a little bit try learn about the definition. What is the 1 electron volt? 1 electron volt is the energy. Is that the energy? Okay, gained by an electron when it had been when it has been accelerated by a potential difference by a potential difference of 1 volt, and 1 electron volt, that is equal to this energy, and you say that there is energy SI unit is a joule. Why you write that 1 electron volt like that? 1 electron volt means 1.6 into 10 to the minus 19 joule. There is a minimum energy required from electron to emit from metal surface and can be supplied to these are some 3 physical process. Okay, this energy supplied, okay, mainly that these energy supplied to the electron, there is some 3 physical process, and these 3 physical process is called light, heat and field. Light, okay, heat and field. Suppose we discuss the heat, is called thermionic emission. The main three physical process. Thermionic emission means there therm means a heat. This name suggests also the heat. There is a the name heat. So there is obviously a heat here. By the suitable heating, a sufficient thermal energy can be imparted to a free electron. Okay, and that's enabled to overcome that come out from the metal surface. Okay. By suitable heating, by suitable heating, the sufficient thermal energy okay, can be imparted to the free electron, obviously free electron, okay, to enable them to come out from the metal, to come out from metal. There is some heat. This concept is heat. Okay. First physical process, and the second physical process is electric field, or called field emission. Means there is apply some electric field. Okay, apply some strong electric field. Suppose approx 10 to the power 8 volt per meter. We apply this strong electric field here to the metal, and that's the metal have some free electron. Okay, and the electron can be pulled out of the metal, is like a spark plug. That now the electron pull out of metal. This look like a spark plug. And the number 3 is a UV ray. Okay, it's called photoelectric emission. Photoelectric emission. So what is photoelectric emission? Photo means light. Photo means some light. When a light of a suitable frequency, so light have suitable frequency, okay, and illuminated to the metal surface, falls on metal surface, and metal have free electron. Okay, so these are electron are emitted from the metal surface. Okay, and also electron emitted from metal surface, okay, emitted from the metal surface, and these are for light. Okay, the light also generated some energy here. Okay, light means a photo means a photon, so generate some electron at this electron metal surface, and the electron gains some energy from that light and escape from the metal surface. And these call when electron, actually another important point here, when the electron gain energy by the help of light, and release from the metal surface, and this electron is called photoelectron. When the electron moves, we get some current here. So that's that current also called photocurrent. This current is called photocurrent. When electron is moving, the charged particle is moving, we get some current, and that current is called photocurrent because the electron released from metal surface with the help of the photon or some light energy. Okay, so that's why these are called photocurrent. Okay, that's a basic concept of the dual nature of radiation and matter. Okay, that's actually the basic idea. And next class we discuss the what is a photoelectric effect. Okay, that's a very important concept. Okay, so today in the class here, if you have any doubt, okay, so please ask in comment section. I will try to give the answer. Okay, so today in the class here, thank you.